All right, thank you. It's always humbling when two of your heroes invite you to give a talk and then they're in the audience too. So I will try and not embarrass myself today. So thank you, Dick, for inviting me, and Paul. So economists fundamentally study how individuals make decisions in a world that's characterized by scarcity and how their actions influence societal outcomes and how our actions influence our individual well-being here. The scarcity we generally think of, or that we talk to undergrads about, is scarcity imposed upon us by the natural world and technology. So if we think about the time period since the Industrial Revolution, things have changed a little bit, largely by combusting massive amounts of fossil fuels to power the growth of an unimaginable amount of wealth over the past 150 or so years. Now, wealth and well-being that came along with that development is, of course, a good thing, but there was a price, and that price is part of the reason we find ourselves here today. So with each ton of CO2 we emit, if you attended the previous panel, you know that we're changing the climate that everybody today, and people hundreds of years, face and interact with. So 1 ton of CO2, in case you don't work on this stuff, is roughly equivalent of taking your academic's favorite car, the Honda Accord, getting in it in Cambridge and driving all the way to Berkeley, California. You emit about a ton of carbon dioxide. Now, why do economists work in this particular field? I think we're useful in 2 particular areas here. One is, and that has to do with the last panel today, is the area of mitigation. How do we write and design policies that achieve goals at least cost, which is a desirable thing? But another subset of us works on trying to quantify the impacts of climate change in monetary terms. So that brings me to what I want to talk about for a little while today, which is the most important number that you've probably not heard about very frequently or ever, the social cost of carbon. The social cost of carbon is one number, and what that number tells you is the damages that 1 ton of CO2 emitted at one point in time, right now, does over its lifetime, let's call that a few hundred, maybe 1,000 years, around the world across all sectors. Seems like an easy thing to calculate, right? So the Obama administration embarked on an effort to actually calculate that number, and I'll give you a little bit of background on how they went about that. But it was an interagency working group that did that and came up with this monetized value. It's mid-afternoon, we're all a little bit tired, so let's take a vote for a second. Who here thinks if you drive your Accord from Cambridge to Berkeley, California, you're causing more than $500 worth of damage on the global climate system? All right. Who here thinks more than 300? More than 200? If you said more than 500, your hands should stay up. All right. More than 10. All right, excellent. Now I need my slides. I don't know how I get those to come up here because I brought them for you. Excellent. Clicker, it's $42 per ton of CO2 is the number that was calculated by the federal government a few years ago. So why do we need that number? Some of you might, on ethical grounds, object to the notion of monetizing anything. For example, should we measure the value of a human life in dollars? We can have a discussion about that in a minute. But if you're a federal regulator, you need a number such as this. So for example, if you design new regulations to improve the fuel economy, right now we're not improving it, we're making it worse, but we'll get back to improving it, I hope. If you improve the fuel economy of cars, you prevent certain amount of CO2 to be emitted into the atmosphere, so you prevent damages. And those damages in benefit cost calculations have to have a number, right? So if you're emitting 10,000 fewer tons of CO2, what's the value of those foregone damages? You multiply them by 42 and you get a number that you can use in benefit cost calculations that the federal government has to engage in. So the question then becomes, how do we actually get to that number, and why didn't it exist before? And the answer to that, as with many things, it's really, really difficult. So what you need is something called an integrated assessment model. This is not a model that's somewhere on the fringe of economics. The Nobel Prize last year went to Bill Nordhaus in part for the development of an integrated assessment model called DICE. And what an integrated assessment model does is it creates a scenario of the future. So it makes some assumptions about emissions of greenhouse gases going forward over the next 300 years or so. Then puts them in a simplified climate model to tell us something about what temperatures and sea level rise will be from that path of greenhouse gas emissions. And then comes the part that I'm going to spend the rest of my time talking about, where the model actually goes one step further than what you've heard so far in these symposia, where we're trying to translate the physical changes into monetizable damages. So how does a higher temperature translate into changed energy consumption, into changed agricultural yields, for example? Talk about that some more. Then what you do is you run this whole model in sort of a baseline path, then you add a ton of CO2, I mean a unit of CO2, not a lot, and you run it again, and you look at the difference in damages over the next 300 years, you add them up, bring them all into present value terms, and that gets you the damages that 1 ton of CO2 causes over its lifetime, the so-called social cost of carbon, this all-important number. Now, the issue here is that most of these models that the federal government used, that lots of people across the world used, they were written in the late 1990s, early 2000s, and most of what we knew about economic damages in the 1990s and early 2000s has changed quite a bit. The data explosion, you read the words big data all over the place, but this is certainly true here, and I'll give you some examples. Data have exploded, computational ability has grown, our understanding of causal inference in statistics has grown, and machine learning seems to be everywhere these days. So these advances in science have drastically improved the way we actually calculate these economic damages today, and helps us update the social cost of carbon. So if you had your Hanukkah or Christmas wish list for what a damage function would actually tell you, it would have a bunch of characteristics that sound rather nerdy, but are really important and really stress how important this is and how challenging this actually is. First off, you want there to be a causal relationship, right? You really want to know if temperature goes up by a degree, just because of that increase in temperature, by how much does electricity consumption go up at peak times? You don't want this confounded by changes in urbanization, changes in incomes, and anything like that. So you really just want that climate signal. You also want it to have global coverage. Does electricity consumption respond the same way in the United States to hotter temperatures as it does in India, in China, in sub-Saharan Africa? The answer is no, right? So you need locally specific mappings of temperature and climate variables into economically meaningful outcomes. It has to be valid for centuries, and this is the really tough one. If you had to tell me in 1819 how humans cool their indoor environment in 2019, I think you would have gotten it wrong, right? You wouldn't have assumed that there was some box on a wall, then you would use electricity that would magically bring down your temperature almost instantly by 10, 15 degrees. So we need to make assumptions about adaptation technology in all sectors going out hundreds of years, which is, of course, a tricky exercise. We need to deal with extreme changes. So we know something about how societies and urban systems and rural systems are affected by hurricanes, for example, because we've experienced them. So we have things to say about that. What's much harder to do is say something about extreme events that we've never experienced in recorded history. So think about, for example, the slowdown of the thermohaline circulation, right? I have no observed data on that. So saying something about what happens to economic well-being of humankind going forward, if that happens, is a really difficult thing to do. Finally, it has to cover all, or at least all, important sectors. So this is not just agriculture and electricity. This is conflict. This is productivity. This is water consumption. This is biodiversity. This is species migration. This is coastal ecosystems, mangroves, and so on. So we're talking about, to me, one of the most ambitious exercises in economics to date, and one of the most intellectually exciting exercises to date. So let me spend my last 4 minutes and 55 seconds a little bit on where we are. I was told there are undergraduates in the room and graduate students here. Sometimes you go to these talks where experts tell you, don't worry, we've got this. We don't got this, okay? We need much more work on many sectors. There's things to be done on methods, on computation, on sectoral coverage, on interpretation, on communicating these results to the public and to policymakers. So let me just briefly walk a little bit about what I think our current understanding of sectoral impacts is, and maybe excite you a little bit about the work that's being done here. So market damages are damages on things that have some sort of market value. They're traded in markets. The best example here is agricultural crops, corn, soybeans, cotton, for example. When these models were written, we didn't really have very fine-scale data on crop yields for large areas. What we have today is we have field-level yields that are remotely sensed from space, covering the entire globe. So there's just been a data revolution in what we know about what yields are at the field level, and we know what weather was at the same time. So we can parameterize, using machine learning techniques, borrowing from the causal inference literature, these yield response functions that tell us something about how, for example, corn responds to hot days. What we learned is that corn really dislikes temperatures that are hotter than 29 degrees. I'm European, I don't know what that is in Fahrenheit. So 29 degrees Celsius, yields drop drastically. What climate change does is it shifts the weather distribution to the right, so you get a higher frequency of the hot days, and you get much hotter days than you did get before, and that increase is nonlinear. So what we've learned there, because of that kink in the yield function, is that even for the little bit of climate change where the weather distribution shifts to the right, the impacts on yields, prices, trading patterns, planting patterns can be quite drastic. Now, does that actually affect the social cost of carbon? Fran Moore at UC Davis took 10,000 of these yield functions that people have estimated, stuck it in an integrated assessment model, and looked at what happened to the social cost of carbon. Just updating the damage function, using these better data and better methods, she showed that the social cost of carbon, just by doing it for this one sector, doubled. Right? That's not doubling $42, that's a different number, but it has massive impacts. We see something similar if we do this in electricity, where the sort of takeaway message there is, if you get a lot more days that are very, very hot, and days that are so hot that we haven't experienced before, the electricity grid is under extreme stress because it's built for the hottest or the peak day. And what we're going to have to do is build more peaker infrastructure, which is really, really expensive because they're essentially plants that only operate on a couple days a year. Do we know everything about markets? No. We have almost no understanding, for example, on water markets, right? How does water consumption respond to this? Seems like an important topic to study, so go ahead and do it. If you want another list of sectors, I have one right here for you. The second thing we have very little understanding about is the consequences for non-market goods. So let's call human life a non-market good. So we can talk about what the value is later over a glass of wine, but there's this amazing study by Tamara Carlton out of the University of Chicago. They've assembled the largest data set on human mortality that I've seen with almost global coverage, and come up with a way to estimate the climate change impacts on human mortality and the costs to not die by investing in air conditioning. And they show that the willingness to pay per ton of CO2 for mortality alone is $36. So again, if you get the mortality impacts right, you're almost, at 90% of that social cost of carbon number that the government uses. So it seems like every time we update these individual sectors, the number goes up. More work needs to be done on extreme events. This is the conveyor belt thing, but you could also think of the thawing of the permafrost, for example. There we ask experts. Some of them are in the room. I see them sitting over there. where we ask people with really good process understanding what are the physical consequences, and then think through carefully what the economic consequences are. I'll close with a pitch here to worry about distributional impacts. Every time I talk to somebody about climate change impacts, when we talk about distribution, it's the standard sentence, oh, the poorest will suffer most. We can do better than that. We want to know which societal groups where are going to suffer most when, so we can really target adaptation strategies towards these communities to make sure we can do as much as we can to protect the most vulnerable groups to this global problem. If you're interested in this particular literature, there's something called the Climate Impact Lab at the University of Chicago, Berkeley, and Rutgers, which does really great work on this. Resources for the Future, a think tank in DC, has picked up what the federal government is currently not doing. And there's another project for the undergrads here. It's called the mimiproject.org, mimiproject.org. All the integrated assessment models that the federal government used were translated into open source models, and you can build your own damage functions, modify these as you want, and inform climate policy by helping improve these models. So thank you very much.
Good afternoon, everyone. I'm just waiting for the slides to come up. I'm Kathleen Hicks, and I want to talk to you a little bit today about the national security implications of climate change, which is definitely more than a 15-minute conversation. So my hope today is to sort of hit the wave tops of the ways in which the national security community thinks about this broader issue set and hopefully generate some ideas for further discussion. So the national security community actually came relatively quickly to, or early, oh, this isn't working, hold on. Always assume user error. Chinese or the Russians? All right, well, maybe the control booth can do it from up there. So the national security community actually came relatively early to a recognition of the concerns around climate change. Sorry?
You're just trying to go to the next slide.
Correct.
Green arrow.
Thank you. Thank you. Nope. Let's do that again. So this is a quote from an intelligence community assessment from 2008. And the gist of that quote is that global climate change is judged to have wide-ranging implications for U.S. national security interests over the next 20 years. This is just the first of a number of documents that have been released, including during the course of the Trump administration, on the national security implications of climate change. Now, why is the national security community so much further along, if you will, than the political debate in the country? I think there are really three reasons that come to my mind. The first is it's a planning culture. The whole way in which the national security community operates is that it's accustomed to and even designed to be having foresight, assessing risk, looking long range and around corners. The second piece is it doesn't just assess risk, it's super paranoid about risk. So the national security community is trained to identify and avoid risks wherever it can, because basically the stakes in security are considered to be high. It's constantly looking and nervous that it hasn't captured areas of risk. And the third is that it's essentially a trained community of experts, and it respects other trained communities of experts. And in that sense, there really hasn't been a view from the national security community that should question overall scientific community viewpoint. And instead, it sort of sees it as a common community or a like community and has adopted the same viewpoint. So if you've heard about national security implications of climate change at all, it's possible you've heard this term threat multiplier, and that's how people often think about or talk about national security challenges of climate. And I'm going to talk today just about three areas, again, very broadly, in which you should think about this threat multiplier effect. The first is it makes the weak weaker. This is something Max brought up in passing. That is that climate is an exploiter of vulnerability. The second is it creates unwelcome opportunities for authoritarians and the strong. In other words, that it can create exploitation of the shifting geographic environment. And the third is that it is imposing costs, some of them financial and direct, on the US military. So I'm going to walk through each of those areas. So this is a global vulnerability, climate vulnerability map from 2017. And what it's showing you is the interaction of governance capability and the effects of climate change, right? So where you see red, it's telling you that not only are climate effects significant, but here are areas where governance is judged to be quite weak, whereas in the greener areas, governance is judged to be stronger and the effects are somewhat mitigated. So, again, climate change often isn't seen as something that can directly trigger conflict, but it certainly is an accelerant of instability. It exacerbates underlying socioeconomic and political challenges, puts pressure, for example, on water resources, food production, livelihoods. It also can foster radicalization and crime, socioeconomic unrest, mass migration, and interstate tensions around many of these resource issues and other stressors. 95% of the cities, 234 cities considered most vulnerable to climate change and are often the least equipped, as you see here, are in Africa and Asia. And thus, climate change is really hitting hardest on those least able to cope with it. This really does, in turn, create these risks that directly affect the United States national security community. And that's around risks of humanitarian disasters to which we may decide we want to respond or be a part of an international response, breakdowns of civil society that can threaten things like economic markets or allies and partners that we hold dear, can create law and order challenges, disease outbreaks, crime rings, things of that sort can exploit these areas, and as I mentioned, migration. I'm just going to touch on a few of these, actually 3 of these security trends. So food security. By 2050, the world population will increase from 7.3 billion to 9.7 billion, with more than half of that growth occurring in Africa, and much of it in these red areas you see. Meat consumption, for example, is projected to rise nearly 73%, and dairy consumption, by 58% over 2010 levels. And this is about rising standards of living, people having greater expectations of their dietary intake. But we're in no way on pace to meet the productivity gains necessary to meet this demand, right? So there's a huge amount of research underway today, also, of course, on water, but on food security and ways to increase productivity in order to ease some of this vulnerability that we're seeing from climate effects. Another major area is migration, both the likelihood of migration and the particular patterns that we're seeing. So there's even, as some of you may be aware, a climate link clearly being seen from the flow of migrants coming from Central America across the US border, because climate change is severely affecting farming conditions in places like Guatemala, and you can see on this map that red area of Central America. And lastly, I want to mention urbanization. This is one I think gets the least attention. Today, the most urbanized regions of the world are in places like North America, Latin America, and the Caribbean, even in Europe. But increasingly, the parts of the world that are moving toward urbanization are, again, Africa and Asia. They are still mostly rural, but they are expected to significantly urbanize in the coming era. That's about by 56% of Africa being urbanized by 2050, 64% of Asia being urbanized by 2050. And if you think about where urban areas lie, often they lie on what we call the littorals, on the waterways. And what does climate change affect? Sea levels, it affects storm severity, and this increases that both possibility and severity of major humanitarian disasters along in these urbanized areas. Urbanized areas are also very difficult to govern effectively, so if you're already in a region where governance is a challenge, having a megacity there that's struck by a major disaster that's climate-induced or climate-accelerated really creates challenges from a security perspective. Not really showing up on this map, but related, is the sea level rise challenge that's being presented to the Pacific Island nations. So there, you're talking about a truly existential threat Places like the Marshall Islands, where they are already expecting that by 2030 they may be underwater. That's a nation, 55,000 people. This is where you get terms like climate refugee. We're also seeing challenges of, if you will, the strong. This is a NASA map. It's a time lapse of Arctic ice melt, and I think you can guess how this is going to go. Nowhere in the world is the geopolitical competition that is climate related happening more than in the Arctic. The region is hotter than it's been in the last 4,000 years. And as my CSIS colleague Heather Connolly points out, as this high north is opening, transits of the Bering Strait have more than doubled in just the past decade. So here you're seeing a whole new region for competition over resources, economic potential, and even geopolitics. So as a reminder, sometimes people forget the United States is an Arctic nation manifest in the territory of Alaska, and of course the US territorial waters beyond the Alaskan coast. And there's lots of natural resources in the Arctic. You have everything from obviously oil and gas potentiality, as well as minerals and rare earth metals. So let's talk about a couple of the actors that are taking advantage of the changes in the Arctic. First, Russia. So since 2014, Russia has built or reopened numerous naval and air force installations in the Arctic. It's invested in its Arctic naval capabilities and in cold water resilient weapons systems. And it's launched even a series of war games in the region, to include one just earlier this month. So Russia isn't invulnerable. It has 14,000 miles of coastline to defend. There's a reason it's interested in the Arctic from just that perspective. So stepping up its investment makes sense, but at the same time, many of its Arctic neighbors are very worried about this Russian step up. And of course, many of those Arctic neighbors are members of the North Atlantic Treaty Organization, including, of course, the United States, Canada, and Western Europe. The other major actor that we're seeing, perhaps not as obvious, is China. One of the most notable Arctic developments that we've seen is the growth of Arctic trade routes between the Pacific and Atlantic. So those are about 25 to 33% quicker and thus cheaper than the traditional Panama and Suez Canal routes between East Asia and Europe and North America. China has thus declared itself a near-Arctic nation, which isn't a thing, as the kids would say. They've just invented the term, and they've announced something called the Polar Silk Road. And as obtuse as it was for President Trump to press for purchasing Greenland, that was likely born somewhere far back in a conversation or a briefing he was given on the very real topic of concern that China has significant investments in both Iceland and Greenland, including investments from state-owned companies in things like rare earth metals and petroleum assets. The United States, as I said, also has its own shoreline to worry about, but it's making far fewer investments in the Arctic. And this is creating a real cause for concern among allies and partners, and in a small set of analysts who look at this region. So just as one example, Russia today has 40 functioning icebreakers. These are ships that can pass through the Arctic with ease in all conditions. They have additional planned. China has 2 such icebreakers, and they've announced plans for a nuclear icebreaker, meaning it could go for longer durations. And the US Coast Guard has 1 icebreaker and has plans for 1 more by 2024 and another after that, but it is way behind. And this creates challenges as simple as search and rescue issues for the United States. It creates challenges in sort of helping researchers who are out there. It creates challenges in seeing what's happening in the region where we don't have the assets to do so. And then, of course, it creates the potentiality of a geopolitical competition or economic competition where the United States is ill-equipped. Okay, last thing I want to talk about is the impacts on the US military. So the Department of Defense has its own very direct financial reasons to be worried about climate disasters. The very first photo that had just the sort of the title slide was a picture of the Hurricane Andrew effects on Homestead Air Force Base in Florida, for those who remember that in 1994. This was a base that we had to shut down because of the effects of the hurricane. But today, the Department of Defense operates over 550,000 different facilities around the world, all of which are facing some kind of climate effect. Obviously, the greatest effects, back to my point on the littorals, the waterways, are about naval and Coast Guard facilities and other facilities that are along sea lines. But there are places beyond that where we've had challenges, and this is Nebraska, which is not near, as you might imagine, an ocean. So here we have, in 2018 and 2019, extreme weather events inside the United States that affected this base, Offutt Base in Nebraska, Tyndall Air Force Base in Florida, and Camp Lejeune, which is in North Carolina, costing more than $8 billion in damages just in 2018, 2019. U.S. assets are also often called upon in humanitarian disaster responses, or even here at home in things like the wildfires in California, or something like a Hurricane Katrina or other hurricane events. You call up military assets. And then, of course, beyond the military, you have other parts of the national security community, such as the Federal Emergency Response Management Agency, FEMA, which is called upon to provide assistance in those disasters. So the costs, the real costs in national security terms to climate change have been growing and are noticeable. Over $100 million in supplemental appropriations, for example, just for disasters at home in 2017 and 2018. So let me close just by saying climate is a national security concern that is not debated within the national security community, but it is still treated as a tertiary subject within the field. That is changing, and it's going to change, I think, quite significantly, quite rapidly, as many of the effects that I've talked about here today play out. Thanks very much.
Thank you. So I have a number of good questions for our panelists, but I am reminded to remind you, first of all, how to send them, and second of all, to keep them short. If you sent in a brilliant, very long question, it didn't make it through. The software has a character limit. So I can't explain that. So let me ask Max. Isn't the social cost of carbon dependent on assumptions about what mitigation methods will be developed and when they'll be developed and deployed?
So I always think of mitigation and adaptation as sort of two separate things, right? So mitigation is how are we going to reduce emissions, and adaptation is how are we going to deal with the crazier environment or the warmer environment. Where the two sort of meet is if all of a sudden all your electricity is made by renewable sources and it's essentially free, right? So if you can turn on your air conditioner and run it 24/7 and set it at 62 degrees Fahrenheit, I'll run it, right? It's free, there's no cost to us. So the question here does become, if mitigation drives the costs of these fuels down really, really drastically, it might make adaptation really inexpensive and might drive down the estimated damages. Playing soccer with your kids outside will still be incredibly uncomfortable in 110 degrees. It'll still be incredibly dangerous for people who can't have access to these maybe better technologies and newer technologies, because installing them might be costly. But there is this very, very valid linkage. So there's always the caveat, what happens even 50 years out is a big question, but it's a good point.
Somebody once said, forecasting is hard, particularly about the future. So, it's not that funny really, but Kathleen, one for you, a nice, simple, easy one. Does President Trump's denial of climate change impede DOD's ability to prepare?
Yes. It creates challenges, certainly there are many ways I can answer this, but I'll start on Capitol Hill. It creates a lot of challenges in terms of the military pressing for priority infrastructure shifts, dollar investment shifts to deal with mitigations of climate, because climate becomes politicized, right, in that sense. So what you'll hear are workaround terms like resiliency. Resiliency is a big one. Infrastructure improvements, readiness investments. There's lots of terms of art that will be used to try to give everyone have a hear no evil, say no evil, see no evil approach to make those investments anyway. But there's no doubt that it dampens the willingness to put, to sort of go forward with a lot other than what you absolutely have to, because there's going to be political challenges to that and some cost to it. So yeah, it creates a lot of challenges.
Max, here's the question. Could we overestimate the social cost of carbon? I guess most researchers are looking only at the bad impacts of warm weather.
So
People are moving from Boston to Atlanta. Atlanta is warmer.
So there's the notion that, climate gets warmer further north of Iowa, and all of a sudden we discover that those Canadian soils are even better for wheat if you only had the right weather, which you now have because of climate change. And, there is a chance that that might make things better. Every study I read, and I don't just read the negative ones, right? Scientists read science no matter what the conclusion is. Most studies I see, there are very few of those where we're like, wow, this might actually make things better compared to the number of things that we uncover that seem to make things worse. But there are certainly things. If you have a huge natural gas bill in California for heating in the winter right now, which is, I live in California, my biggest bill is natural gas in the winter. My bills will go down. Our winters will be milder. The cooling in the summer is cheaper than the heating in the winter. So yes, there's a benefit there. It's outdone by a whole bunch of other things, as I'm crudely reminded by the fact that we just got, an evacuation warning, one neighborhood over from the wildfires. So lots of unknowns, but unfortunately, I hear more bad news than I hear good news here.
Kathleen, can you say a word about cities? Someone wants to know what makes cities particularly vulnerable. Wouldn't you think the organization and so forth might make them better able to respond?
Yeah, a well-governed city, yes. There are advantages in urbanization. There are a number of advantages to urbanization in general around issues like education, healthcare, and if you have a well-functioning city system, if you will, even law and order kinds of issues can be stronger. The challenge is in the areas where governance is already weak and these cities are growing up without all that. So you can imagine a place like Rio, of course, where you can even probably envision in your head the way in which the city has developed without much governance structure. And it's already, even without bringing the climate piece in, is already creating challenges to issues like law and order, criminal gangs, poverty levels, et cetera, where if you then introduce a massive disaster, you think about quality of water, you think about nutrition, you think about disease outbreaks, and then now you have areas that are densely populated, so you're affecting many more people, and the conditions will get worse very quickly.
Max, how do you price the possible collapse of civilization?
How do you divide a constant by zero? I mean, it's very, very high. And, yes, I'm worried.
Exactly.
I have a kid. When I look forward into his future, he's going to live in a much less friendly climate than the one I grew up in. But this is part of what we're supposed to be doing, right? Climate change is baked in now. Even if we stop emitting greenhouse gases right now, temperatures are still going to go up. Any reasonable economist will tell you that we're not going to stop emitting carbon tomorrow. It will take us decades to get off this train. So it's up to, I think, fruitful collaborations between engineers and social scientists and political scientists specifically to help us develop the technologies that are cost effective that we then roll out in the right settings to minimize damages from climate change as well as the costs imposed on society from it. That was a long sentence.
It's a good one. Kathleen, what does the DoD plan to do at sites like its facilities in the Marshall Islands and I guess Norfolk that are really threatened? Is there an elaborate contingency plan? And is it cheap?
Well, the second piece is easier. No, it's definitely not cheap. And I think this goes back to these mitigation plans that are underway. I think in select cases, there will have to be more drastic measures. Marshall Islands is a great example where I don't know what they're planning today. I have no doubt, again, because they're planners, they're trying to think about where they shift assets in the long term. Places like Norfolk are harder because there you're into a domestic political environment in which the threshold for saying to the state of Virginia that we are going to move a major military base out of your state, that seems extraordinarily high. And also we need to have naval assets accessible to the ocean, so they have to be somewhere. So that really leads you more to the mitigate. They're not going to be in Nebraska absent a shift in the oceans that's significant. So there you're really talking about mitigation plans. The Congress does require a report, and DOD put one out this year. It's a little half-hearted, honestly, but it does identify the facilities of greatest concern to the U.S. military. That's accessible online. I can't remember the name of it off the top of my head, but it's essentially the bases or facilities of greatest concern to DOD from climate change. And so, again, they're sort of trying to do what they're told, but survive, to have this discussion in greater form some future day. I think right now they're lying low, no climate pun intended, and they're trying to do what they're supposed to do in terms of doing the planning, but call it lots of other things and do the minimal amount until they can get into a conversation where, the country is more comfortable talking more directly about climate change.
One hopes that's soon. Max, here's a little supply side, demand side question. Shouldn't the social cost of carbon be the cost to capture and sequester a ton of carbon?
Ooh. So carbon sequestration is the sort of big unknown at this point. One of the issues here is, of course, that those aren't cheap experiments, right? Each major carbon sequestration experiment costs, what, $1 billion or something like that? So these are big ticket experiments. If you get a technology that actually works, and engineers sometimes are very happy when things work, and then the economist comes around and says, well, but what does it cost to operate this thing for each additional ton sequestered? So it doesn't just need to work, it needs to be cost competitive with other ways to abate carbon at scale. It's a mitigation technology, right? So I think we're on the mitigation side, chasing down a variety of different technologies that might get us there. One of the most effective ones I can still think of is the negawatts or whatever it was called at the time, right? Just don't consume the kilowatts, and the carbon doesn't go up in the air. So energy efficiency and thinking about when you turn on your lights, even though if you do the calculations now with LED lights, turning off your LED lights doesn't save that much electricity anymore, so turn off your air conditioner. But back to the question that was asked, one sort of deals with the marginal cost of abating one unit, the other one measures the discounted stream of damages, and they meet in the middle somewhere. So we need to figure out both. Economists often get snarky when it comes to carbon sequestration. They sort of say, oh, it's like clean coal, we'll get it. It's only 10 years away. And then 10 years later, it's another 10 years away. It might work. It would be amazing if you do it through the air or you pump it in the ground and we turn it into drywall, whatever we did to other pollutants. But I'm a little bit worried that we're going to figure this out at scale quickly enough. So I think pursuing multiple avenues here is what we should be doing.
Kathleen, do other countries, particularly our adversaries and allies, think about climate change as a national security issue or opportunity as we do?
On the adversary or just an unfriendly actor side, I'm actually not sure. That's a good question I haven't thought much about. I can tell you on the allied side, the answer is yes. And you can think, obviously, of places like Japan that are significantly affected by climate, let alone the UK and others. So yeah, there's a lot of commonality among allies of the United States and the United States about national security implications of climate in many of the ways I've just described all along, the sort of the weakness, the geopolitical competition, and the direct cost elements. I'm not sure that China and Russia look at it that way. I don't think there's any significant writing that's out there from their thinkers, if you will, but they also are much more bifurcated into more strictly military communities and then sort of civilian science communities, and it may be that they just haven't crossed over yet.
Max, how should we use the social cost of carbon? It's a number. You mentioned regulation. There are a number of questions that point to the social cost of carbon as a carbon tax. Is that a fair linkage? And if so, where would you go with that?
So let me give you the academic answer, not the snarky one. So the social cost of carbon is fundamentally a number that we've constructed for rulemaking. If you emit one more ton, right, what's the cost, the external damage or the external cost that additional ton imposes on global society over the next 300 years? A carbon tax is a number that how much is the external cost exactly at the amount of consumption, at the optimal amount of consumption that I need to charge you to consume the optimal amount of carbon-containing goods. There's a subtle difference here. The snarky answer to me is you may possibly ignore the subtle difference here because the uncertainty around the social cost of carbon and the optimal carbon tax is probably not insignificant. So a well-calculated social cost of carbon is a ballpark estimate you could use. If you want to know what the optimal carbon tax actually is, there are people like Bill Nordhaus and Larry Golder around that would love to talk to you for hours about what the optimal carbon tax actually is. But the difference between a carbon tax and the social cost of carbon is the carbon tax you actually pay directly. The social cost of carbon is something that lives in a spreadsheet where the federal government decides whether to pass a new regulation or not, and you don't actually pay it.
Thank you. I think we've come to the end of this session. Please join me in thanking our excellent speakers.
Thank you.